And here there's some control boxes. Essentially what I've got here is a temperature monitoring box and the main voltage monitor and control box, and this one's sonics because I've built in a sonic system. Sonic frequencies affect these type of electromagnetic reactions.
Right.
The idea is to use frequencies to control the overall effectiveness of what's going on in the machine, ramp up the power or even suppress it down. And it's also creating a more controlled environment, because if you've got sonic frequencies from outside, it can affect the machine.
Yeah.
You'll notice that everything in this design is about simplicity and symmetry.
Yeah. I understand.
It has to be that way because it's a matter of efficiency. It's the way that nature does things. Yes.
Okay, yeah.
And it's also simplicity and safety. You'll see I've used a lot of triangles so that it's a very strong structure. If you've got something heavy inside that's spinning fast and it chucks out of alignment, what's going to happen? So I've designed it in a very safe manner. These black bits between the mounting things are rubber. They're like shock absorbers. These mounting frames to some extent absorb a bit of movement so that it's a stable, and yet it's still got a little bit of give from the rubber.
Yeah.
There's some side connectors on the side, make wires, go to control boxes. And I've designed it so that the sides here come right off easily. The side comes off, but the frame is still in place, holding it all together. So you can work on it without having to take the whole thing to pieces. What I've done here is I'm slowly disassembling it so that it's not throwing you in at the deep end. 3 of the sides here taken off. You can see basically what's inside it. In the middle, at the top inside, there is like a switching mechanism with just a simple arrangement of contacts. I'll show you that just later. Then these things around are coils, basically a ring of coils. Here we've got coils in the center as well as the bearings for side differential gears. And at the bottom we got a big fat coil that goes all the way around. The idea behind that is the tough thing about generating this sort of electricity is you don't just need volts, you also need amps.
Right.
Making volts is really simple. Okay, what I've done here is I've sectioned it. I've told the machine to chop it in half and leave the center bit so that you can see the center bit highlighted. Sorry, it didn't section it 100% correctly. Kind of left 1 or 2 stray pieces. So the machine is chopped in half, and you've got the central core that isn't chopped in half. And the middle is like a ball which is in 2 halves attached to an axle. And at the top of the axle there's a bearing, and at the bottom there's a bearing. And that's another ball at the bottom attached to the axle with more magnets in it that spin around inside the coil. In the 2 halves of this larger ball, again you've got arrangements of magnets, natural magnets. I've chosen neodymium magnets because they're the most powerful natural magnets. And the ball itself is made of silicon nitride because it is very strong, very heat resistant, and most importantly it's invisible to magnetism and it doesn't conduct electricity. My coils are slightly different as well. I've thought to use a percentage of copper and silver, a small percentage of silver in the copper, because it helps it to conduct much better.
Right.
Far, far better. Silver's got a much, much better conductivity.
Okay.
The problem with silver is it's got much less of a heat threshold.
Yeah, it's softer, isn't it?
Yeah,
much softer.
exactly. But all you do is you put like a small percentage of silver in the copper mix of the wire that you make. Every bit of wire in this machine is that silver and copper, because it's all about conductivity, and everywhere where you join a wire with a connector must be a pure silver connector, because then it's got no resistance.
Yeah.
And you don't get any loss of the juice flow between the connections, especially if you join coil to coil to coil.
Yeah.
That's how this arrangement essentially works, is these coils are just joined loops. And so all the coils are essentially joined together, and at the end feed out. What I've done was I chopped now the whole thing in half, including the middle section, and I put some labels on it so that you can have a look-see. And you can see the center bit here is 1 continuous axle, and at the bottom 1 axle as well. The blue is steel.
Right.
This grey is aluminium. The cores of the coils are made of very soft compressed iron. But if you go to a shop and you say soft iron, they give you a metal that they've named soft iron. But that isn't soft iron. I don't know if you ever remember those old crystal radio sets where you have a tuner, which is essentially a little long coil.
Yeah.
And it had like a black core that was like soft. That black core is soft iron. And it's actually soft. You can squash it. And I've very specifically chosen that soft iron because it works the best.
Okay.
And that has been proven from work that lots of other people have done. And it's very strange that nobody uses that soft iron nowadays in generators. There's been a lot of debate about one whole solid core working better or an arrangement of multiple cores working better with a copper winding around it. Right. Oh yeah, you see the sound holes there at an angle and the arrangements of the speakers. And if you could draw a perfect circle around that because it's spherical, the way I've designed the arrangement.
Yeah.
Right, so now you can see the differential section, that the top half and the bottom half are joined with a gear. And inside the ball and inside this axle you can see a cord hole, which is where the wiring goes. Now at the top here is the switching arrangement. There's a bunch of contacts that are mounted on the actual central axle.
Yeah.
So that when the axle spins around, they also spin around. They're just brushes sticking out. And just around the outside is an arrangement of fixed contacts mounted, which feed the juice through. So when the contact comes past, connections made, feeds the juice through.
Right.
Just for a moment. On these two halves, you've got the arrangements of the drive magnets that make the thing turn. Okay, this is the central core, and you can see the contacts there for the switches sticking out. And you can see on the top here you've got active magnets, electromagnets, inside the top half, and two other magnets in the bottom half there. I'll show you how that works. Right, this is the frame that holds the differential bearings.
Yeah.
It also holds the mountings for the coils. This goes inside the main frame and it's got adjustments in it. You see here you've got 3 gears.
Yeah.
And they're the ones that go between the 2 rings. Here you can see there's 2 gear rings, one on the bottom and one on the top.
Yeah.
And that's very simple gear, and those go between. You see?
I see, yeah.
So it has a differential gear. And if you turn the top one this way, the bottom one will have to turn.
Yeah, the same speed.
Yeah, and I've done it like that because of how the sequencing works that switches it to actually drive it around. It's a very clever little trick. And also in here, I've put some other normal coils. There's a load of spinning magnetism going on there. So if I put more coils in proximity, maybe you get some more juice out of them. And again, these coils here, you can adjust them side to side and in and out. Also the other coils, you can adjust them. Now we'll have a look at the switching mechanism inside the main machine, and right at the top this is what goes there, so that the axle kind of goes through that hole at the top. And that's those little contacts sticking out of the axle that spins around inside here, so these contacts go past these points and fire them to feed juice through. That's what it looks like when it's assembled. And again, you can adjust it. It's mounted with a ring inside so that you can adjust it a bit if it's firing too soon or too late, for example.
Yeah.
Yeah, and that's where it mounts. I've sectioned that switch here. So you can see it with the axle going in it. That's the bearing at the top. And those are the contacts that'll contact past those things. They're in pairs because you have electricity feeding through, positive and negative.
And that goes into the centre bit?
Yeah, then when these are attached on a ring fixed.
Oh, and it goes into the ring.
Yeah, and then so the centre bit spins around inside it.